another videos from PLC programming series, and today we are going to talk about the up down counter. So in our previous video we actually talk about the up counter and down counter. So if you didn't watch them, please check the link in the top of the screen and you could watch those videos. And in both of them you learn how up counter works, how down counter works, and today somehow we are using the up down counter, which is somehow is a combination of these two counters. So let's see how we could add the up down counter to our ladder logic in TIA portal. So as usual, you comes to the instruction, go to the counter operation, and the third counter that you see will be CTUD. So you drag and drop anywhere that you want. So here I just want to show it to you. So I say OK, and then it's add in this location that I actually drop it. So this is exactly the same thing. So I already did that. I'm going to eliminate the new one. So as you could see, the up down counter has 5 input and 3 output. So the input output is very similar to up and down counter. So the first input is CU, which is the pulse of the up counter. So that means whatever you give here. So in up counting mode, it's actually counting this input pulse. So you have the similar things in the up counter. So the next is CD. This is a pulse of the down counter that you have here. So these pulse actually used for down counting. So you have R and LD input, which you had in the up counter and down counter. These are for reset value in up counting. Whenever you active that or give 1, so it's actually initialize 0 inside your counter. Whenever you active this input, which is the LT, it actually set the PV value in your counter. Here I put PV is 5, so definitely whenever you active this, it's actually initialize the 5 inside these up down counter. So that means these are exactly the same input which you already had in up and the down counter. Somehow you see here for all of them. So take a look to the output. So the same output we have Q up, QD, and CV. Q up is the output whenever you have up counting. So whenever you active these reset, it initialize the 0. If you got the pulse here, it's counting, and whenever you reach to the 5 or over 5, this output will be active or 1. If this is less than 5, this should be not active. So the QD, the only difference here in the QD, it's not output. Even if you want to connect this, it's not let you do that. It is a Boolean value, which is just true and false. So instead of being active, it's just say true or false. True means you have set here or you have 1. False means you have 0. So exactly the same function that you have in down counting. So that means you set your value, it's initialize this PV, which is 5. So then in all of them this is false. The only time this is actually true or 1 is whenever you are in the 0 or less than a 0 or negative number. You will see that. So and the CV is the current value. No matter you are in the up counting or down counting, this one all the time shows what you currently number, the current number in your ups down counting. So you could find all these explanation in the documentation or help section of your TIA portal. Go to the help and open the help. So we did the same in up and down. So you just search this time for a CTUD. So CTUD is what I'm going to type, CTUD. So which is CTUD is up down counting. I say search, and then you find this one, which is the first one, and this is count up and down. And again, this is the table that you could find all info related to the input and output. Very similar to what, even the same label. So CU is count up input, you get the pulse that you are counting up. CD count down input. R is reset input. LD is the load input, or we call set whenever you active that these value initialize inside the counter. So the PV value at which the QU output is set, value to which the CV output is set when LD is 1. So again, whenever this says uh, LD is 1, it's actually initialize this value inside your counter. So QU is the status of the up counter, is the output for up counter. QD is the status of the down counter, and CV is the current counter value. So you could find more info, more detail here if you are interested to take a look. So let's do back here and check these circuit that I made here. So let I do one thing. Let I see. I already compiled the codes and loaded. So let I see it is able to go to the live mode. Yes, it's good. So let I do turn on my video to use at the same time you could see the PLC. Let's see what we have. So I add one up down counter here. So for the CU I connect to the one toggle switch that we have, which is in input 0. So the second for the CD, which is the pulse for the down counting, I connect that to the input 2. So the reset connected to the input 1, and the LD connected to input 3. So if I show you what's going on here on my PLC, so see this is 0, 1, 2, 3, which is these 4 LED that you have is related to these 4 input. So the first one, clock pulse for up, this is for resetting, so I put close to each other. This is up counter pulse, this is reset, this is the pulse for down counting, this is a for set. So clock pulse for up, reset, clock pulse for down, and set. Okay, so that's what happened here. So here is the PV is 5, and the only output I use is Q0, which is this one, is just for the output of the up counter. Okay, so as you could see, this value is the output of the down counting is just true and false. You couldn't add. I don't know why, for some reason, you couldn't have the output like this. This is just as true false, and you could use this as initial memory and update the memory and use in the other place of your program. So, and the current value is shows the current value. It doesn't matter you are in up and the down counting. So what I'm going to do here, I want to show here this is exactly could work as a up counter. Then as a second scenario, I use that as a down counting. So the third scenario I'm going to show you, I'm showing you you could actually use that in the same time as a up and counting. Somehow in the third scenario, whenever you use both of these clocks in the same time, it's able to subtract whatever you already count. So that means if you count these 3 times, then you count 1 times, what you see in the output is the 3 minus 1, which is the 2. So that means with this, you could increase the value that you have in the output, and with this, you could decrease that value with sending the pulse here, which is a very cool features and has a lot of application. So let's do this. So this is our plan. So 3 scenarios. One, I use this as a just up counters, show it is exactly similar with up counter that you see. Number 2, I show its work as a down counter, and number 3, I will show you you could somehow use both in the same time. So let's do use first as a up counter. What's happening in the up counter? So first you want to start it, you go, so these two is related to the up. This is the pulse and this one is the reset. So why I should do if this is the up, I first reset it, you see the reset is active, so you check that. Or if I active these reset, it is 0, which is right. Here you have in the current value 0. So then if you get any pulse on your this input, which is the pulse for up counting, it should be start to count. So see, I go 1, 2, in all of them still this is 0. So I go up 3, 4, and whenever it is 5, it should be turned on. We saw this in up counter. If you didn't watch the up counter video, check the link that you have in the top of this screen. So then in the 5 it is on. If you go up, so still it is on. See on my right 8, 9, and you see you could see the current value in these two places. Okay, so I want to reset. I reset it back to the 0, same story. You could go up, and again whenever you are 5, its Q is on. And again you could reset it whenever you want. Okay, so that means exactly I use this and able to use that as a up counter. Now I'm going to use these two inputs and do that as use that as a down counting. So where is my input? So this one, this is input 0, which is these guys. Here is the pulse for down counting, and this is the set value, which is LD. So as usual, I want to use as a down counting, I use the set, so it's initialize the, it actually initialize the value of 5 here. So then if you give the pulse, it should be go down, right? So see, this is 4, this is 3, this is 2, this is 1, and see for all of them this is false. This the only time this is set whenever you are on 0, right? We had this in the down counting. So now I'm in the 0, it should be changed to the true. You see it's changed to the true, that's right. If I go even more down, -1, -2, you could see this is exactly still is a true. So again, set it, it's back to the 5, this back to the false. So then again, if you counting down, it's going to actually to the 1 and one more, it goes to the 0. This is true, the QD is true, and even you could go negative. So again, I reset that again. So just see this, whenever I reset, this is 5, and check the Q, U, the output of the up counter. So whenever you use the set, this is 5. Whenever this is 5, this should be active, right? So which is makes sense. So again, if I go down, it's go down, and whenever you are on the 0, this one should be true, which here you see it's true. So let I reset that. Maybe I back and set it again. Okay, so what I show here is exactly the same thing that you see in the up counter and down counter. So that means here you could use these up and down counting as a up and down counter. But most important one is somehow you could use as a combination of them. So let's see how we could do that. So now I'm in the I reset the counter, it got 0. Let's just increase these pulse. That means count a little up. I go 1, 2, 3, 4, and see now I'm going to send some pulse here and see what's happened. Whenever I'm counting up, I got some pulse for down counting input, which is these input that you see. I got for see this goes actually down whenever you actually get pulse for the down counting. So see you go down, okay? So even if go more, it goes negative. So now I'm in -3. Let I send some pulses in up down in up counter. It's go -1, -0, 1, 2, 3. Even I could go up and up 5, 6, 7. Now I'm in the 7. Let to send some pulse to the down counting. So definitely should be go down, right? So see I'm going 4, 3, 2. Now I'm on 2. Let to send some pulse in the up counter is again is go up, which is these very cool features. So it has a lot of applications. Suppose this one is the sensor that counting in parking lot how many cars get in, and this is a sensor that count how many cars is output. So that means all the time whatever you see here is the subtraction of up minus down or enter minus exit cars, which that means these numbers shows how many cars currently you have in your parking lot, and it's a very nice info to send in the entrance of the parking lot. Whenever it is full, you could actually know with this number it is full. You could turn on the light and other application for that. So In our next video, we are going to do that. We are going to design and use these up-down counter to show one application of that, which is in somehow design a system that shows what is the capacity of the parking lot. It is full, it's turn on the light. If there is a available spot, it's actually turn the other light for the people who want to enter to the parking lot. So I hope you like this video. So stay with me in the next video, which I'm going to have one real application of counters, which we are going to use a PLC. So thank you for watching this video and see you all in our next video.